Hi, in this example we'll do, in this video we'll do two more examples of taking derivatives of the natural logarithmic function. All right, so now in this one I want to find the derivative of f of x, so f prime of x, of natural log of 2x divided by x plus 3. And now we could potentially do it this way that I describe up here, letting u be 2x over x plus 3. But the easiest way to do it is to go ahead and apply our rules of logarithms, which tells us division goes hand in hand with subtraction. So I can rewrite this natural log of 2x minus the natural log of x plus 3. And now I'm taking the derivative of this whole thing. Okay? So now I can simply take the derivative of each piece, derivative of the natural log of 2x. Remember that the derivative of the natural log of x is simply 1 over x, okay? And then I have to take the derivative of the 2x. So this actually becomes 2 over 2x, okay? Or look over here, the derivative of this divided by the whole thing, okay? And then I can take the derivative, subtract the derivative of the natural log of x plus 3. Okay, and again I can use that same formula over here. I'm going to subtract, and it's just going to be similar to the example we just did, x plus 1 or x minus 1, sorry, it's just going to be 1 over x plus 3. And now that is a legitimate answer, but we want to get one denominator, so I'm going to find a common denominator. Well, first notice that over here my 2's would cancel. I have 1x minus 1 over x plus 3. Getting a common denominator of x plus 3, my numerator becomes x plus 3 minus x, okay, because I need to multiply this by x plus 3, top and bottom, and multiply this by x, top and bottom. Notice my x's cancel out, and my final answer would be 3 over x plus 3. F prime of x. Okay, I have one more example. This one's again going to employ a rule that you already know about, and that is the quotient rule. Recall that the quotient rule says that if I'm taking the derivative of u divided by v, that is equal to v derivative of u subtract u derivative of v all over v squared. Okay, low d high minus high d low over low low is how I remember it. Okay, all right, so now we're going to employ this. We've got low, which is t squared, and then g prime of t. It's going to equal, we've got low, which is t squared, d high, the derivative of the top. Notice that again we're employing that the derivative of natural log of x is 1 over x, so the derivative of natural log of t is 1 over t. Okay, we're going to subtract natural log t times the derivative of the bottom, which is 2t. Right. And all that is going to be over v squared, or the bottom squared, which is going to become t to the 4th. Because t squared times t squared, all right, becomes t to the 4th. And now I can just simplify. T squared times 1 over t just leaves me a t. Over here, I'm just going to rewrite that by bringing the 2t in front, natural log of t. And all of that is t to the 4th. Again, I can simplify my numerator by pulling out a t. I get 1 minus 2 natural log t over t 4th. My reason for doing that is this t would cancel with this and leave me t cubed. So my final answer would be that the derivative of g of t is 1 minus 2 natural log t all over t cubed. So again, we've employed all our old derivative rules, the power rule, the quotient rule, the product rule, and now we've just snuck in there the fact that anytime I take the derivative of the natural log of x, it's 1 over x. Hope this helps.